Using the law of sines, we need to show that in a triangle ABC, the ratio sine of b minus c to that of sine of b plus c equals b squared minus c squared over a squared. So let us begin. So first we'll specify the law of sines. So we have a triangle ABC. Here the letter A, B and C in lowercase represents the sides opposite to angle A, B and C. Then the law of sines states that the ratio of side A to that of sine of the angle opposite to it will be equals to the ratio B to that of sine of the angle opposite to it, and it's also equals to the ratio of the side C to that of the sine of the angle opposite to it. So this is the law of sines. Fine. Now what we'll do, let's begin. We'll start from the left hand side of a given problem. So here we have sine B minus C whole divided by sine B plus C. Okay, so let's do one thing. We're going to multiply both numerator and the denominator with sine b plus c, that is the denominator part. So we have sine b plus c multiplied to sine b minus c whole divided by sine squared b plus c. Now, the numerator portion, sine b plus c times sine b minus c, so that's a standard formula. So this is actually sine squared b minus sine squared c. So when we expand sine squared b minus sine squared c, we should get the previous numerator, that is sine of b plus c times sine of b minus c, divided by, now here we have sine squared b plus c. So what we can do here, we can use the fact that we know a plus b plus c, the sum of the interior angles of any triangle that sums up to pi radians, or 180 degrees. Now, if we keep b plus c on the left hand side and transpose a to the right hand side, we get pi minus a. Now we will be taking the sign on both sides. So we get sine of b plus c, that will be equals to sine of pi minus a. And what's the value of sine pi minus a? So that's simply sine of angle a, because we have an even multiple of pi over 2. So pi can be also expressed as 2 times pi over 2. Fine. And it's positive because pi minus a lies in the second quadrant, meaning we can replace this b plus c simply with a. So we get a sine squared a in the denominator. Now, in using the law of sines, so if we consider, let's say this ratio is equals to a constant, let's say 1 over lambda, that in that case, we can say that sine of a will be equals to a times lambda. Then sine of b will be equals to b times lambda, and similarly sine of c will be equals to c times lambda. So we can substitute these three values in place of sine a, sine b and sine c, and we will finally get b squared minus c squared over a squared. So this is the expression on the right hand side. Hence we have successfully proved the given problem.